All right, let's do question 8 here. Let me zoom out a little bit so you can see all your answer options. Um, Before you go and hit pause, let me give you one little piece of advice, and that is to the way I say it in class is always make it look better before you integrate it, right? Um, you may look at it and be like, say what? Or if you know integration by parts, you may be like, let me try that, right? No, 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 no. Distribute this guy into that one and this guy into that one, and then do the power rule. And if you do that correctly, it's like a fluid short process. So hit pause, do it. Now let's go over to my answer. I got C, 16 over 15. So let's talk about how I got that. When I distributed this in, I did x to the half times x, which is x to the 3 halves. Um, Remember, say I had like x to the 6th times x to the 3rd, right? Well, the x to the 6th would be 6 x's times 3 x's. How many x's total do I have? 9. So what's the rule when I multiply this through? I add them. So this is 3 halves. That would be 1 plus a half. And then this distributes and gives me x to the half. From there, I power rule it, and it looks pretty terrible, but I'm evaluating with nice numbers, 0 and 1. What's more than 3 halves? 1 more than 3 halves, 5 halves. Do my 2/5. That's power rule. Same thing here, power rule. And then I evaluate from 0 to 1. Just like one of the previous ones that I talked about, this is a nice thing to evaluate because what is 1 to the 5 halves? It's just 1, right? 1 to the 3 halves, whatever it is, it's just 1, right? So I just get the coefficients. 2/5 plus 1 plus 2/3 minus this thing evaluated as 0 is just going to give me 0. And then I did some common denominator work right here. I multiply by 3 over 3 and 5 over 5. So I get 15ths. There's 6 of them. That's 6 is 2 times 3. 2 times 5 gives me 10. Add them, I get 16 over 15, which is C. Next one. Question 9. All right, so I have same type of thing here. I'm not going to give you any hints except for watch your negatives. And go. Here comes your answer. Hopefully you got that one right after the last one. I got D. When I distributed this into those guys, x to the 3 halves, x to the half, there's a minus. It's almost exactly the same as the last one. I get 2/5 x to the 5 halves minus 2/3 x to the 3 halves plus a constant. So D. Next one, question 10. Here I got a definite integral with some trig work. It's pi over 4. You guys should know pi over 4. It's that 45-degree angle. Just watch your negatives, especially on this one. Hit pause, give it a shot. Here comes your answer. All right, so sine integrates to a negative cosine x. Hopefully you got that negative. And I got to evaluate that from 0 to pi over 4. So it is negative root 2 over 2. What is that? Remember, here's my here are my 2 spots in the unit circle that I care about. And we're doing cosine, so I'm taking this guy and that guy. That's because cosine is the x coordinate on the unit circle. So you may say, what's this negative doing here? Well, that's this negative. Cosine of pi over 4 is this. So I get that. Minus, that's part of the integration. Anytime we integrate, we subtract in the middle. And then this negative slides in here. And this one is that one. So what do I get? Double negative here. So that one is positive. And then this, I just like wrote this and then looked over and said, oh, that's this guy. So the answer is D. Next one, question 11. All right, integral of 1 over x squared. Power rule, not an ln. Negative exponent. What's 1 above negative 2? Here comes the answer. Right, this is the same as the integral of x to the negative 2, which is x to the negative 1 divided by the exponent, negative 1 over x. Well, this one looks easy. This is one that, like, this gets everyone, right? I mean, so many people write this. I feel like that's the most common answer, incorrect answer right here. Or this one where you like sort of do a derivative, I guess is what they did there. But anyway, the answer, or maybe a negative 1 over that, right? Um, anyway, the answer is C. Hopefully you see it now. All right, 26. Oh man, what am I doing? I need to read question number 12. Sorry. Oh man, it's the same thing, except for it's got bounds. Let's see if you can do this, guy. Hey, pause, do it. Don't just sit and wait. Come on now. All right, here comes your answer. It's negative 1 over x squared. I know that from negative 1 over x. I know that from the last one. So I'm just going to write negative 1 over x valued from 1 to 2. When I plug in the 2, I get a 1/2, the negative up front, minus, when I plug in the 1, I got 1 over, this is the one that's being plugged in. This is that negative. So it's double negatives positive. 1 minus a half is a positive half. Answer C. Okay, next one is question 13 here. This is your first U sub problem. So hopefully remember your U sub. You got some negative exponents. Go ahead, hit pause, see if you can do it. This might be your review of U sub right here. Hopefully you can do the U's the next time around, right? I got D. I'll walk through the whole thing here. I let U be 3x squared plus 5. That's this thing. Remember, I make the U as big as I can. I don't just take the 3x squared. I take all of it. And it's the thing that's interior to another equation, another function. So all that is interior to a root right there. The du is the derivative of this. It's 6x, and there's a dx on the outside. And then look, I got a 6x here. Here I just got so I got a 6x dx here. Here I just got an x dx. How do I balance that? Well, I divide this by 6. 1/6 is x dx. And this is my substitution step. This 1/6, I always just write it out front of the integral just to get it out of the way. And the du is in the top. And then I've got a root u in the denominator. Now this is the tricky part of the integration here after you do the u sub. I got 1/6. This is a u to the negative half. So you need to add 1 to that. Well, what do we get to? We get to a positive half, but then I need to divide by a half. Well, that's the same as multiply by 2 over 1. So these cancel a little bit and give me a 1/3. And then I sub the u back in and get 3x plus 5 plus a constant. So my answer is D. Oh, I guess I apologize if some of these are they don't show up well and you can't read them super well. That's as best as I could get it from the way that those AP files got imported. So before you do this one, this is another one where it got formatted weird. This is not x times 3. This is x cubed. Okay, so that's an x cubed minus 3x dx. This one you should be able to do. It's just power rule. All right, here comes your answer. Integral x cubed minus 3x dx is 1/4 x to the 4th, that's power rule in this guy, minus 3 over 2 x squared plus c. So my answer is E. I hope you got that one. All right, question 15 here. All right, so the second derivative is this mess. Which of the following could be f, right? So it's not saying what is f, which one of these could be f. There's a couple strategies here. You could just integrate. I think that's the way I would do it. Well, I know that is the way that I did it. Silly. But I just integrated it. Or you could take the derivative of each of these. That might be too much work. Just watch your negatives with the trig. Pause it, do it. Don't just wait for me to go. Okay, here it comes. All right, so my first integration step, do some power rule, x squared. I get my minus sine x. That's because sine derives to a positive cosine. This is already negative, so this stays negative. Plus, I wrote c at first, right? But then I realized I was getting another c here, so I just back tagged that as c1. Just write the first constant, c1. When I integrate again, I get 1/3 x cubed plus cosine x. Why is it plus? Because this is negative, and cosine derives to a negative sign, so that's already set up for me. Plus c1 times x plus a new constant, c2. Well, when I look over here, I can see that even if I messed up over here, only a and b have the x cubed over 3. Hopefully, could you see that well here? Moderately. It's really about getting the sign of the cosine correctly. So this guy is plus, because that guy's plus. Here, this would be one with a c1 value of -1 and a c2 value of 1. All right. What do we got next? I'm going to stop here for this video, and I will pick it up in the next one. So see you soon, or goodbye.